Hello, chemistry students. Today we're going to talk about Gay-Lussac's law. Now, Gay-Lussac's law states that the initial pressure divided by the initial temperature is equal to the final pressure divided by the final temperature. And if there's an increase in temperature, that means there is an increase in pressure, which means that pressure and temperature have a direct relationship, which also means when one goes up, the other goes up, and vice versa. So if we have a decrease in temperature, then the pressure will also decrease as well. Now, where you see this every day is the air pressure in your tires. It will increase on a hot summer day and vice versa. When the temperature gets cold, the pressure will decrease. So on a cold day, your tire pressures will decrease, and usually people have to air up their tires more in the winter than they do in the summer if there's no leak. Now let's do an example calculation. If the pressure on a gas in a rigid container changes from 800 millimeters of mercury to 2.15 atmospheres, and at the lower pressure the temperature is found to be 40 degrees C, what was the original temperature in Kelvin? So let's write down our variables. See, our initial pressure is 800 millimeters of mercury. And our final pressure is 2.1 atmospheres. We already have a problem here. The pressures are in different units. We need to convert them to the same unit. I'm going to go ahead and convert atmospheres into millimeters of mercury. So I'm going to draw my dimensional analysis grid. Units I have on the upper left go on the lower right. And what I want to convert to goes on the upper right, so millimeters of mercury. Now I'm going to look on my star reference sheet and find under conversions, constants and conversions, and find out what the relationship between millimeters of mercury and atmospheres is. And I see that there are, for every 1 atmosphere, there is 760 millimeters of mercury. I have an atmosphere on top and an atmosphere on bottom, so they cancel. And 2.15 times 760 is 1,634 millimeters of mercury. Now our initial temperature is 40 degrees C. We always have to convert our Celsius into Kelvin, so we're going to go ahead and do that right now. We're going to add 273, and that is 313 Kelvin, and we are looking for our final temperature. All right, since we're looking for our final temperature, we need to get the T2 on the top, and we need to get it all by itself. So we need it to look like T2 equals. So in order to do that, the first thing we're going to do with this equation is to get T2 on top. So we're going to do the opposite of what's happening here. It is P2 divided by T2, so we need to multiply to get T2 on top. We're going to do the opposite of division. And whatever I do to the right side, I must do to the left side as well. So I'm going to multiply the left side by T2. I have a T2 on top and a T2 on bottom. They cancel and they go away. And now I have T2 times P1 divided by T1 is equal to P2. Now what I must do is get rid of the P1 and T1 on this side and move it over to the other side of the equation. So in order to do that, I have to look at how they're related to the variable that I want to keep on this side. So P1 is multiplied by T2, so I have to do the opposite, and I'm going to divide by P1. Whatever I do to this side, I must do to the right side, so I'm going to divide it by P1. I have a P1 divided by a P1, so they go away and they cancel. Now I have this T1 that I need to move to the other side. Since it is T2 divided by T1, I am going to multiply it both sides by T1. Sorry, this is a little cramped here. I multiplied that side, the left side by T1, so I must multiply the right side by T1. And over here, I've got a T1 divided by a T1, so I'm going to cancel them out. And I am left with, my new formula is T2 is equal to P2 times T1 divided by P1. Now I'm going to insert just plug in my, now I'm just going to plug in my variables. So P2 is equal to 1,634 millimeters of mercury times T1, which is equal to 313 Kelvin, divided by P1, which is equal to 800 millimeters of mercury. Now let's cancel our units. We have a millimeters of mercury on top and a millimeters of mercury on bottom, so they go away and cancel. And I'm left with Kelvin, so my new temperature is going to be in Kelvin. So I'm going to take 1,634 times 313 divided by 800, and my new temperature is 639 Kelvin. Thanks for watching.